Hi, this is Simonas. In today's video, we're gonna look at inversion routine. It is a data evaluation procedure to obtain particle number size distribution from raw data measured by custom-made TROPOS-type mobility particle size spectrometers. Inversion routine includes multiple charge correction, optional corrections for diffusional particle losses, condensation particle counter efficiency, and so on. As this video will be a simplified, more practical version of the inversion procedure, you may refer to internet page for more details if desired. To run the inversion, you will need custom-built software which you can find online as well as MPSS data. Specifically, diagnostic and raw files, which can be found in the corresponding folders in your MPSS data folder. Please copy both diagnostic and raw files into one directory on your computer. For simplicity, I will copy these files into directory where inversion software is located. To run the inversion, we have to first set the configuration file which will communicate to software how the procedure must be executed. For this, we open the initialization file for the SMPS data evaluation. Although the inversion software requires configuration file to be in .txt format, the easiest way to set it up is to use more graphical text editing software. At first, after opening the configuration file, you might be overwhelmed by the colors and complexity of the file. Don't worry, I will explain you which entries are the most important and has to be checked. First of all, your root directory. This is very important. It says where is your MPSS data located. That is the directory where you place your MPSS raw and diagnostic files. Please note that there is a backslash at the end of the line. Make sure that the path to your root directory is as short and simple as possible. Do not make a mistake here, as it would result in software failure to perform the inversion. Next, we have to set what will be our input and output files. Let's start with input. For batch file inversion, it is important to correctly describe the file prefix. As you may have already noticed, MPSS saves measurement data with date embedded in the file name. In this case, all our measurement files start with letters SMPS, followed by the full date in a format of year, month, and date. For this reason, our prefix will be SMPS 20. To avoid possible software errors due to wrong prefix definition, I recommend to batch invert at most 1 year data at a time. Now, let's set up the output file. In most of the cases, only final inverted data is desired. Therefore, we will only enable SD level 2 as our output. This will give us the particle number size distribution corrected for standard conditions. To enable or disable the desired output, we type either on or off. The inverted files will be saved with extension of .in2 in the same directory where raw and diagnostic files are located. In basic evaluation settings, we do not want to change anything, as the default settings presented here will work most of the time. Only if you have specific needs, for example you run TDMPS and not SMPS, you may change settings here. The same can be said about settings for DMA transfer function, reducing number of bins before inversion, and setting the extrapolation. Unless there is a specific need to change these parameters, I would suggest leaving it as default. In reading diagnostic parameters section, you may want to define the minimum, optimum, and maximum values for aerosol and DMA sheet flows, temperature, and relative humidity. In case your system runs with 1 liter per minute aerosol flow and 5 liters per minute sheet flow, you do not need to change anything. In data evaluation parameters section, activate multiple charge correction must be on. For TROPOS type MPSS system, type of charge is always 0. DMA transfer function parameter A0 in case system runs with 5 liters per minute sheet flow and 1 liter per minute aerosol flow has to be 0.2. However, other parameters are also possible. For example, if your system runs with different aerosol sheet flow ratio than 1:5, simply divide your aerosol flow by sheet flow and enter the value here. DMA transfer function parameter D0 leave as 0. In scalar CPC efficiency field, we leave the correction as off. It is possible to include CPC efficiency correction if such information is known. To do so, you can activate correction function 1 by setting it on and providing the path to custom CPC efficiency curve. For example, here is the CPC efficiency curve derived for specific CPC. On the left are the particle diameters in nanometers, and on the right are the counting efficiencies. For this demonstration, we will leave correction function as off. Next, we might want to correct for particle diffusion losses in sampling lines. This can be done by defining the length of pipes and the sampling flow. To enable the particle diffusion loss correction in a segment, please set the binary value to on. Equivalent lengths of elements, for example Nafion driver, neutralizer, DMA, and so on, can be found in Wiedenzoller et al. 2012, Table 1. The inversion software also holds the standard CPC efficiency correction for certain CPCs. However, I would recommend to use custom measured efficiency curve, as the counting efficiency for CPCs may change over time. Please note that here the estimation of particle losses in the sampling lines is rather limited. For example, not only segment number is limited, but also the type of losses is limited to only diffusional. Therefore, I would strongly recommend to calculate particle losses using separate software after the inversion is completed. One of the final sections to be set for inversion are the parameters for standard temperature and pressure. In our case, it is 1013 hectopascals and 20 degrees Celsius. To have the standardization performed, please turn this parameter on. In our case, I will leave it off. Last but not least, I would also recommend to convert size distribution to a new grid, setting this option to on. New grid start and end diameters of 10 and 800 nanometers respectively are suggested. New grid number of bins is chosen to be 40 and the interpolation type is linear. When the configuration parameters are finally set, it is important to save them as a TXT file, which can then be loaded into inversion software. Give me a second to do that. Now we can open the inversion software, for which I use version 2.16. It needs to be mentioned that to run the program you will need LabVIEW runtime engine. For more details, please refer to internet page. When you first open the program, do not get intimidated by the complex appearance of user interface. There is also a high chance that you will get an error popping out at first. This is because program tries to execute with default parameters, which for our case of course are incorrect. Just click stop to fix this issue. The only thing that we have to do here is to set path to our prepared configuration file, which will take care of the rest. We need to give the full path with any file name. Give me a second to do that. When this is done, please make sure that file list option is on if you want to invert more than one file. By clicking on Run Arrow, we will initiate the inversion routine. We can see that the program successfully loaded configuration file, which determines the file prefix, what output we desire, and so on. Also, it automatically popped the window where we can choose which files to invert by measurement day. In our example case, we know that measurements were performed between May 1st to May 15th, 2020. Therefore, let's set the time frame accordingly to include all the measurements. When the time frame is set, we have to press enter your numbers. If everything is set correctly, on the right you will see the recognized file list. In case procedure fails to load the files, please restart the routine by closing the listing window and pressing run arrow in the main window once again. Triple check the prefix of your files because this is where most of the problems come from. When software recognizes your file list, click Confirm to initiate the inversion procedure. Software will automatically process all your files and output the final result to a file with extension .in2. Congratulations! Now you have your particle number size distribution, which can be corrected for particle losses in the sampling lines.